One application of triple integrals is to compute the mass or the volume or things like that of a given region. So what we want to do is find the mass of the region bounded by the curves given. If the mass density is delta equals yz, and let's say the units are kilograms per meter cubed. So in other words, the volume, or the mass, I should say, of this region is going to be the integral of delta over the region. Now we just have to figure out what the limits on the integration is going to be. So the first step is to visualize what this region looks like. So I've sketched what these curves are in the yz plane. So y is equal to 2z squared, y is equal to z cubed. I've sketched that in the yz plane. And so again, this is going to be similar to the previous problem. This is going to be a cylinder, but not a circular cylinder. It's going to be a cylinder, and these are going to be the cross sections. This part that I'm coloring in again in green. These are going to be the cross sections. And the x-axis, the positive x-axis is going into the screen, and the negative x-axis is coming out of the screen. And what are the limits for x? Well, x will go from the plane x equals 2 minus y to the plane 2 plus z. So in this problem, it's best to have the x integral be on the inside. In other words, how I've given it. The function that we're integrating is yz. Okay, and now whether we put the y integral first or the z integral first doesn't really matter. I just want to integrate in this way, which means I'm going to put the z integral first. So for every fixed value of z, y will go from z cubed to 2z squared. So notice for this problem, you had to observe that z cubed is smaller than 2z squared for this part that we care about. And now the z integral is going to go from z is equal to 0. Now we have to find the z coordinate of that point. So z equals 0. What is the upper limit? Well, we need to solve 2z squared is equal to z cubed. Of course, one solution is z is equal to 0. That's the origin. The other one is going to be 2 is equal to z. If we just divide both sides by z squared. So this is 2. And then we have the dy dz. And I forgot to write 0 right there. The inner integral is an x integral. So as far as x is concerned, y times z is a constant. So then this is the integral z equals 0 to 2. Y equals z cubed to 2z squared, and then this is y times z, and then it's going to be 2 plus z minus 2 minus y. So this is z plus y dy dz. And I will let you do this at home. This is 21,760 divided by 693. The novelty of this problem is that we are interpreting the triple integral over a region as being the mass of that region if the function that we're integrating is the mass density.